Hi, this is Alan again on my third and final video to do with macros and an exposition on macros using a concrete real-life example. Let's remind ourselves of where we were at the end of the previous two videos. I set myself a problem. We have daily builds of attributes tied to an individual, and there could be hundreds of these. Then on a subsequent build, on a subsequent day, we want to compare all those attributes, every one of those attributes, with the corresponding attributes in the base file the earlier day, and let's say put out some kind of warning. Now we've got to the stage where we've collated the information into one data set. We can look at this. Come on. Right, so here's the information on the individual. The record ID is the key to that record, and for every one of the attributes now we've generated or retained information on the base value from the first day, then the candidate value for the key file that we're testing, and a percentage difference from the base day here, and that's done for every one of these attributes. And the reason this is pertaining to macros is that there's just too many attributes. There can be literally hundreds or thousands and low thousands of attributes assigned to an individual. So without further ado, let's get on with the ECL. So here now what we want to do with this information, we want to actually act upon it, generate an email, let's say, if certain thresholds are breached, either warning or action email. So we start off with the input layout, which I've shown in earlier emails how to obtain, and this is now the output from the second video is the input to this third video, and D is just that input data set I've just shown you. And what I want to do is, well, firstly, I did it for training, but we don't really need, for ease of display at the end of this video, we don't really need base value and candidate value. So I'm going to run through the same process as I run before on the creating a new layout. So this layout is all the fields like first name, date of birth, etc., except for base and candidate. So I'm removing those from the layout and calling it new lay. So new lay is effectively that layout, but without base and candidate attribute values in it. And I want to create my output record, which is this new layout, plus 4 booleans, which I can set dictating if some threshold has been met or not. And just for example, the 4 thresholds I've decided to flag up as if there's a percent decrease greater than 99%, percentage decrease greater than 95%, a percent increase greater than 1,000, a percent increase greater than 10,000%. Again, it's all a bit unreal, but this is a trading episode. So in the I've got my input data set. It's a bit sticky, and I'm going to just project it through the transform flag up, and flag up really just takes copies across to the output, the input, but also sets these 4 flags using a macro to sweep through every one of the attributes, and I've given it 4 thresholds to compare against. So the macro here effectively routes through the fields again, and really uses the same attribute regex before, or this attribute regex. It's only interested in percentage change attributes, and it wants to generate, as I said in the earlier emails, it's always handy, earlier videos, it's always handy to just write out in comments the ECL that it's generating, and that's handy for future people as well, and reference months, years later. A little trick here is obviously the first construct, you don't want an OR here. That would just be obviously invalid ECL, but you do want an OR and subsequent field. So I have a symbol variable, compiler variable separator set up, originally empty, but after the first time round I pre-penned separator to every one of these constructs for these fields, but the first time round it's empty, and the second time round, all subsequent times round, it's set to the word OR. So that's just a little trick to enable you to construct some kind of these kind of constructs here. Again, I wouldn't actually need to use text this way. I've got to convert that to a string, but I didn't actually have to do it that way. I could have just use that, and it's so slow, goodness me. And put past it across as strings. So you could do something like that, but in fact I didn't. I chose it to do it another way. So that would be equivalent really, and obviously text going there from there as well. Let's just Control Z that. And these booleans will be set up for different threshold values here, and then I'm just outputting these. I'm generating it. So this output from this is F, and really I've got a little macro here that will output a count of F. Again, this is now this is a straightforward, because this is ECL I'm generating directly. ID is just a straight textual replacement, which will work here, but obviously the operand to the named qualifier to output is expecting a string, but this isn't a string, so I have to put this force ID to be a string by doing this. So the hash text is required in this context, but in this context it will just work, as you can see, with a straightforward textual replacement. So that explains that field here, and we'll see what results we get. Then once you've got these flags set up, so this will be true, comparing every one of these fields, you can do things like joining. So we want to find records that have got a threshold decrease more than 95%, but less than a 99% decrease. So that's a bracketing of using flags there, and it's just doing a join of not 99 but 95 true on rec ID. Just transform left, and so we can have a look at that output. Let's see, you have to run this on 4 because it's doing work, and let's see what we get. Again, it's always handy to look at graphs of what you run. This will be very simple. There'll just be a straight read in, a hash distribute, because of that, and then the project, and that will be about it. And I expect we'll split the outputs into various parts to process a lot of this in parallel, but it's so sticky I don't think I'll bother showing the graph, but it's you saw this in earlier videos. Shouldn't take long, as it's not really doing that much, and it's doing it all locally anyway. There we go. So here, let's have a look at all these outputs. There we go. This is 99% decrease, so all this is going to be true, and so there's bound to be a percentage decrease greater than minus 99. So somewhere along here in this, for this person, we'll see a percentage decrease. Let's have a look for it. 95.94, but that's not 99. Let's be 99.7%. So that's caused that to be true. Let's have a look. So you'd see all these others. Let's see what we've got here. This is over 95%. Let's look at the flag, 95%. So here we've got the 1000% increase. So all this, the third column is all going to be true here. Let's get to a very interesting one at the end, which where we're expecting to find a decrease greater than 95 but less than 99%. So effectively all these are going to be false true. So the first two columns in this output are going to be false true, false true, false true. So let's see, and I actually remember that one, where that one was. Yeah, 96.24. So that's a record that's been bracketed. So you've got as fine a control as you like, and of course, given these booleans here, you can then detect a condition that you want to alert people to. I mean, these don't have to be booleans, but you could have you could construct bit masks, but you get the general idea. And really, that's it. We can all go away and have a nice cup of tea. Any questions, put them in the comments, and also it'd be great to have some feedback, because without feedback I'm really not going to improve, and I'm sure there is room for improvement. Anyway, all the very best. I'll see you in the next videos, no doubt. Bye.